Here's a question to start your week. How big can a single thing actually get? Not a country, not an ocean, one object held together as one.
And I'm guessing you don't mean my inbox.
Bigger. Today, astronomers have finally put a tape measure around the largest galaxy we know of and found its edge for the very first time.
Plus, a Japanese spacecraft that just set the record for the closest asteroid flyby ever flown. A British launch put on hold at the last minute, and news that our nearest big neighbor galaxy is quietly powering down.
It's Monday, the 3rd of August. This is Astronomy Daily. I'm Anna.
And I'm Avery. Let's get into it.
So let's start with that tape measure. If I asked you to name the biggest galaxy in the universe, an astronomer would very likely say IC 1101, and they've been saying it for decades. But here's the strange part. Until now, nobody could actually tell you where it ends.
How do you not know where a galaxy ends? It's right there in the pictures.
You'd think so. IC 1101 sits about 1.15 billion light years away, at the heart of a cluster of galaxies called Abell 2029. William Herschel first logged it back in 1790, though of course he had no idea it was a galaxy. Nobody did until the 1920s. It's what we call a giant elliptical, or more precisely, a brightest cluster galaxy, a BCG. And BCGs are the great white sharks of the galaxy world. They sit at the center of a cluster and they grow by swallowing their neighbors, one merger at a time over billions of years.
So it's basically been eating the other galaxies in its cluster.
For most of cosmic history, yes, and that's exactly why its edge is so hard to find. When a galaxy grows by cannibalizing others, it ends up wrapped in an enormous, faint halo of stars flung out into the space between galaxies. That glow is so dim it blurs into the background of the cluster itself. So the honest answer to how big is IC 1101 has for years been a shrug. You'll see figures online anywhere from about 400,000 light years across to a wild 6 million light years. Nobody could pin it down.
That's not a rounding error. That's a factor of 15. So what changed?
A team led by Carlos Marrero de la Rosa took the deepest images ever captured of this galaxy, ultra-deep exposures in 2 colors using the Isaac Newton's wide-field camera. And when I say deep, I mean they were sensitive enough to detect a glow 30 magnitudes per square arcsecond. Faint. In plain terms, they could pick out starlight roughly 1 billion times fainter than the night sky you'd see with your own eyes.
And the trick is separating that whisper of light from everything else.
That's the whole game. Bright foreground stars smear light across the image. The galaxy scatters its own light, too. So they carefully modeled all that stray light and subtracted it, using a detailed map of how the telescope spreads out a point of light. Only then could they trace the galaxy's true profile all the way out until it finally melts into the cluster. And here's what they found. IC 1101 reaches an edge about 260,000 light years from its center, which gives it a diameter of roughly 520 kiloparsecs. That's about 1.7 million light years from one side to the other, holding around 3.4 trillion suns worth of stars.
Okay, I need a yardstick for that. How does it compare to us, to the Milky Way?
Our galaxy is about 100,000 light years across. So IC 1101 is something like 17 times wider than the Milky Way. And en masse, our entire galaxy, including all its dark matter, comes in around 1 to 1.5 trillion solar masses. IC 1101 has more than 3 trillion solar masses in its stars alone. It is, by any measure we can now defend with data, the largest galaxy known.
You said now defend with data. That word now is doing some work.
It is, because the second finding is almost better than the first. This galaxy isn't finished. Beyond that main edge, the team spotted a scatter of faint, lopsided structures, 8 of them, and 2 line up neatly with disturbances astronomers had already seen in the hot X-ray gas of the cluster. That's the fingerprint of ongoing feeding. IC 1101 is still pulling material in, still assembling, probably shaped by a collision with another group of galaxies 2 to 3 billion years ago that's still settling down today.
So it holds the record and it's still growing. That feels almost greedy.
Which brings us to the real question in the paper's title: how large can galaxies actually get? Because IC 1101 now sits right at the extreme upper end of what we call the mass-size relation, the biggest edge yet measured for any galaxy. It's not just a trivia record, it's a data point that tells us the ceiling for how big a galaxy can grow in the present-day universe. And IC 1101 is sitting up there, brushing against it, still reaching.
Can anyone actually see this monster for themselves?
You'd want a good telescope. It's a faint smudge in the constellation Serpens, near the Virgo border, well placed in the evening for both hemispheres right now. But honestly, the wonder here isn't in the eyepiece. It's the idea. Somewhere out there is an object nearly 2 million light years wide, 3 trillion stars strong, and it's still hungry.
From the largest thing we know to a very small, very fast one. Japan's space agency, JAXA, held a press conference last Thursday to confirm a result that had asteroid scientists grinning. Their Hayabusa 2 spacecraft has just flown the closest asteroid flyby ever attempted by any mission.
This is the same spacecraft that brought samples of asteroid Ryugu back to Earth, isn't it?
The very same. Hayabusa 2 launched back in 2014, dropped those precious Ryugu samples in the Australian outback in 2020, and then, with fuel still in the tank, kept going. It's now traveled something like 10.7 billion kilometers on an extended mission. And on the 5th of July, it threaded past a near-Earth asteroid called Torifune.
How close is closest ever?
400 meters from the surface. 400. That's 744 meters from the asteroid's center. And they did it while both objects were screaming along at more than 18,000 kilometers an hour, about 100 million kilometers from Earth. They'd planned to pass 800 meters from the center and beat their own target by clean half.
At that speed and distance, that's
Absurdly precise.
The operations lead, Yuya Mimasu, put it beautifully. He said the difficulty was like shooting a 1 yen coin up on the northern island of Hokkaido from down in Okinawa, right at the other end of Japan. And they didn't just take pictures. Hayabusa 2 pulled off the first ever laser ranging of an asteroid during a flyby, bouncing a laser off the rock to measure the distance in real time.
And there was a surprise waiting for them, too?
There was. Torifune turned out to be a contact binary, 2 lumps of rock stuck together, a bit like a cosmic snowman. Roughly 450 meters of double-lobed asteroid they hadn't expected to look like that at all.
So why do this, beyond the lovely images?
Planetary defense. Learning to navigate a spacecraft that precisely, that close to a moving target, is exactly the skill you'd need to reach, or one day nudge, a genuinely hazardous asteroid. This was a rehearsal, and the next act is already booked. In 2031, Hayabusa 2 will rendezvous with a tiny asteroid called 1998 KY26, just 11 meters across. It might even try to land.
A fridge-sized probe landing on something the size of a house. I love this mission. Now to a launch that isn't happening quite yet, but when it does, it'll be a first. The German company Rocket Factory Oxford, RFA, is aiming to send the first ever rocket to orbit from UK soil, flying from Saxe-Voord Spaceport up on Unst, the most northerly of Britain's inhabited islands in Shetland.
The first orbital launch from the UK. That's a genuine milestone.
It really is. Britain has never launched a satellite to orbit from its own ground. RFA's rocket, called RFA-1, is a 30-meter, 3-stage vehicle designed to carry up to 1,300 kilograms to a sun-synchronous orbit. But last Monday, while running a test campaign on the pad ahead of a hot fire of the engines, the company found what it called an issue with the vehicle that requires further investigation. So they've made the call to destack, to take the fully assembled rocket apart, stage by stage, to get at the problem.
And they've got history at that pad, haven't they?
They do. Back in August 2024, an earlier RFA-1 first stage was destroyed in a fireball during a static fire test at that very site. Nobody hurt, the pad saved, but the stage lost. RFA are open about their philosophy. They develop iteratively, they test hard, and they accept that things sometimes break. This latest issue sounds far less dramatic. Caught on the ground, exactly where you want to catch it.
So what does the timeline look like now?
Their certified launch window opens on the 10th of August. Whether they make that depends on what the investigation turns up. Saxe-Ford matters here, beyond just this one flight. It's the first fully licensed vertical orbital launch site in Western Europe, and the only UK spaceport cleared for vertical launches. With satellite demand the way it is, Europe is hungry for its own independent way to orbit. So this is one to keep an eye on over the next week.
We opened with a galaxy that's still growing. Let's close the news with one that's slowing down. And this one's practically a neighbor. New Hubble work published last Monday finds star formation across the Andromeda galaxy has been fading for the last 500 million years.
Andromeda, that's the closest big spiral to us.
The nearest large spiral, about 2.5 million light-years away, roughly 1 trillion stars, and on a dark night, you can see it with your own eyes. A team led by Benjamin Williams pieced together 2 enormous Hubble surveys covering about 2/3 of Andromeda's disk and measured something like 200 million individual stars. As Williams put it, the stars are the fossil record of the galaxy's formation. Read them carefully, and you can reconstruct its history.
And that history is one of a galaxy quieting down.
Steadily, yes. Its star-forming rate has dropped from about 1 sun's worth of new stars a year to roughly 1/5 of that, with the sharpest decline in just the last 40 million years. Most of what's left is concentrated in a ring about 32,000 light-years out from the center, and there may be a culprit, a little satellite galaxy called M32.
Hit and run?
Possibly a sideswipe. The region of Andromeda nearest M32 shows the most suppressed star formation, and the slowdown there seems to have kicked off around 60 million years ago, which could actually help pin down when M32 last barged through Andromeda's disk. It's a reminder that galaxies aren't serene islands. They jostle, they collide, and sometimes a small neighbor leaves a very large mark.
And you can go and look at the scene of the crime tonight.
You can, which is the perfect handover to the Skywatch.
Skywatch time. And a heads up before we start. We've just had the full buck moon, so the moon is a waning gibbous this week. Still bright enough early on to wash out the faintest targets. It'll get easier as the week goes and the moon thins toward last quarter.
First up, a comet with its moment tonight. Comet 10P/Tempel-2 reached its closest point to the sun yesterday, and tonight, Monday the 3rd, it makes its closest approach to Earth.
It's not a naked eye showpiece. You'll want binoculars or a small telescope and dark skies. From the southern hemisphere, it rides highest before dawn, so Sydney early risers have the better geometry. From North America, it's best hunted in the narrow window of true darkness after evening twilight, but before that gibbous moon climbs up. For mid-northern latitudes, roughly 9:30 to 10:30 p.m. local. Use averted vision and let your eyes settle.
Next, an easy one for everyone. Tonight, the waning gibbous moon sits right beside Saturn, a lovely naked eye pairing, up through most of the night and into dawn, and visible from both hemispheres. If you've got a scope, swing it to Saturn while you're there for the rings.
And for the early risers, Mercury reached its greatest western elongation yesterday, so it's about as well placed in the morning sky as it gets this round. Look low to the eastern horizon roughly an hour before sunrise, over toward the stars of Gemini, with Mars a little higher up. Northern observers get the cleaner shot at Mercury this time, but it's worth a try from the south too. You'll need a flat, clear horizon either way.
Now, a diary note we flagged last week, and it's now just 2 days out. On the 5th of August, a spent Falcon 9 upper stage is on track to impact the moon near Einstein Crater on the western limb at about 0635 Universal Time.
And this one's squarely for our North American listeners. You have the best seat in the house. That impact time works out to about 2:35 Eastern, 11:35 Pacific the night before, with the moon up and the impact region on the dark side of the terminator. Ideal. You won't see a flash with the naked eye, but if you've got a decent telescope and a camera trained on that limb, you're in the game.
For us in the southern hemisphere, the timing's unkind. That's mid-afternoon in Sydney, around 4:35 p.m., with the moon not favorably placed. So we'll be waiting on the orbiter after images of the impact site rather than catching it live. But it's a great excuse to follow along online.
And looking ahead, a quick flag for the big month coming. The 12th of August is a huge date. A total solar eclipse tracking across Greenland, Iceland, and Spain, paired, for once, with a moonless peak of the Perseid meteor shower, plus a 6-planet lineup in the pre-dawn sky. We'll build all of that out closer to the day.
One safety word now, though, and we'll say it every time. If you're anywhere near that eclipse path, you view the partial phases only through certified ISO 12312-2 eclipse glasses or a properly filtered scope. Never look at the uneclipsed sun without them.
That's your Monday briefing. If you want more, everything lives at astronomydaily.io. The full back catalog, a news feed that updates through the day, and a spot to sign up for the daily newsletter.
You can send us a message from the site too. Corrections, questions, what you spotted in your own sky. We read them and we love them. We even got our first voice message today from listener Ian Sama in Uganda, who said, "Hi there, I'm Ian from Uganda and I really enjoy your podcast very much. Thanks a lot." Thank you, Ian. The feedback is very much appreciated.
Yes, thank you, Ian. Very much appreciated by all of us. We'll be back tomorrow with more of today's space news. Until then, from Avery and me, keep looking up.
Clear skies.
Astronomy.